There are 25 trays on a table in the cafeteria. Each tray contains a cup only, a plate only, or both a cup and a plate. If 15 of the trays contain cups and 21 of the trays contain plates, how many contain both a cup and a plate? This is fascinating. All right. So we have 15 trays. 15 trays that contain, so there's 15 trays with cups. So that's that set right over there. And then we have 21 trays. So we have 21 trays right over here. That's this set. 21 trays with plates. And so how do we represent the trays that contain both cups and plates? Well, those are the trays that are a member of both of these sets. So that's this area. That's this area right over here. The section I'm doing in orange, that is cups only. The yellow is cups and plates. And then, I don't know, this green, this would be plates only. So what we really need to figure out is we need to figure out the size of this intersection right over here. This intersection, I'll do it in white. I'm making this messier and messier. We need to figure out the size of this intersection, and we'll just call that x. So given that there's a total of this whole set, this is both trays with cups only and trays with cups and plates. So all of the ones with cups, there's 15. All of the ones with trays, there's 21. And we have x where we have both. What is the total number of trays that we have? Well, we could try our total number of trays, we could say, let's add the 15 trays, which was once again this entire set. And then let's add that to the 21 trays. Let's add that to the 21 trays. But if we did that, we would be double counting this middle section right over here, this x. This x is included in the 15, and it's included in the 21. And so we don't double count it. To get the total number of trays, we would want to subtract the x one time. So now we're only counting the x once. So we're counting an x in each of these numbers, and then we're just taking it out once, so we're not double counting anymore. And this, they tell us that the total number of trays is 25. There are 25 trays. So this is going to be equal to 25. And so now we can just solve for x. We have 15 plus 21, which is 36. We get 36 minus x is equal to 25. We could subtract 36 from both sides. Subtract 36 from both sides. And we are left with negative x. Negative x is equal to negative 11, or x is equal to 11. That 11 trays contain both a cup and a plate. This is equal to 11. And I encourage you, if what I did here doesn't make a lot of sense, now that you have the number, you can verify that. So for 11, if this set right over here, is 11, we know what these other sets were. So 15 trays contain cups, but 11 of those contain both cups and plates. So only cups would be 15 minus 11. So 4 only cups. So obviously the size of these sets aren't really drawn to scale. And then once again, 21 trays with plates. Well, 11 of them have cups as well. So if you said only plates, it would be 21 minus 11, which would be 10. And so this makes it a little bit more clear. When you took this 15, this 15 was really the 4 plus the 11. 4 plus the 11 was this 15. And then this 21 was really the 10 plus the 11. 10 plus the 11. Well, we're counting this 11 twice, so let's subtract an 11 to cancel one of these out. So that's why we then subtracted the 11, so that we don't double count for this middle overlapping section.